punished for being a good friend?
You suck.
There's some notes up here to help. These will not be there on the test though, so don't get too used to them. Just trying to be a good friend. Give you information.
That's it. Oh, yeah.
You're like not supposed to say that.
I didn't get a 180 out of the game, and it's not fun.
For a hot bus. You know what?
It was going like 8 over.
Really? In a 25? That's like
I live in Belleville.
pretty nifty. Was it actually over or was it 20 in the road?
No, I was going 8 over.
One time I was going like 90 and he rode it for 80. It was nice.
But he put it as
The nice circuit in Reddit.
she put it as like NPD, and I think
Exactly.
she remembered before.
Oh, really?
So
Wait, the same person.
yeah,
That's not going to go well.
the first time it was a yellow light, and she told me I ran a red light. And I was like, okay, but it was yellow.
Okay. I mean, that's, but maybe it was.
No, it was yellow.
It was straight up yellow.
It was definitely yellow. She was just vegan. Anyways, and
Yeah, and that's the same per cop all over again.
yeah, and then she put me as a meeting so like my insurance didn't go up.
Oh, that's right.
And I don't have any points on my list. So like I was complaining about the fact that I was really still like
Yeah. Still better.
because like if my insurance would have like that would have made me pay the
It goes up a lot too.
yeah.
Especially when you're like 18.
I'm not even 18.
17,
I'm not even
whatever,
18
but
yet.
when you're young.
I'm not sure.
Yeah, right.
So do I have to do like the whole like
We did yesterday?
like on the packet?
Yes.
Okay. Got it. I thought so.
Yeah, because I didn't tell you. So you always take. Because 0.5 is like your safest guess. It's right in the middle of 0 and 1. It's half the width. Like if you're going from 10 to 50, what's in the middle? So the margin of error is the distance from 30 to either side. Are you good? So I got like 384.1, which you would then say, okay, we need to ask at least 384.1 people. You can't ask 0.1 people, so you bump up to 385. So I'll talk through that in a second also if you want. Even if you don't want to. There's the work, so you can kind of look at your stuff yesterday, check out what you're doing. If you didn't quite get it, let me know if I can help. Like your multiple choice options. 300, 400, 500, 600. That's good.
I was too busy talking, so like I just missed the first one. I was too busy talking, so I just missed the first one.
Yeah, that's not bad.
So you're fine.
What?
Oh, that's what you ran away.
Just what's your sister doing? Yeah, Emily, right? I saw them.
I know that. You can cruise it out of here.
Quiet, please. So, just to talk through this, like in general, I know I want the margin of error to be 0.05. That's this margin of error is 0.05. And then margin of error is this part. It's like the part after the plus minus. It's the part you add or subtract from the middle to get to your endpoints. So that's this formula here. For this, I put 1.96 just to have like an estimate on my paper, but really I'm doing the whole thing in my calculator, remember? Why did I put 0.5 there? It doesn't say 0.5 anywhere in the problem. Because if I don't know what P is, that's just my best guess. It's 0.5. It's the safest guess. It's right in the middle of 0 and 1. I don't know N, and then that's still 0.05. So I divide by 1.96, but again, I'm really dividing by inverse norm of 1.95 divided by 2, and just kind of storing that value in my calculator. And then I square both sides, so whatever this came out to be, I squared it, which was approximately this, but I just left it in my calculator. And then I showed you that little trick where you can just kind of flip-flop these two, and then N ends up being 0.25 divided by that number that you have stored in your calculator. It's like 384 point something, so you come up to 385. Questions on that first one? It's kind of long, algebraic type process yesterday. We good? Alright, then for the second one, I'm going from 10 to 50. So hopefully this is starting to be a little more familiar at this point. The width is 40, right? That's just how far it is from one endpoint to the other. The margin of error is half that. So the margin of error is how far you go each way from the middle. So the margin of error is 20. There's really two of them, but you can just look at whichever one you want. Point estimate is what is exactly in the middle, which is 30. And then plus or minus form would be like 30 plus or minus 20. So the point estimate is 30. Width is 40. Margin of error is 20. Good there? If I increase the confidence level, what happens to the margin of error? So again, think about like if you have to guess tomorrow's temperature, you have to be 100% confident, or the Earth explodes because you were wrong. You're going to say like negative 50 to 50. You have to be, the more confident you need to be that your answer is in the interval, the bigger you want to make your interval. So if you increase the margin, or increase the confidence, I will increase the margin of error also. So that's there. This won't be on the board. Question on those three? Kind of like a second part of the warm up here. I don't wait very long. Other questions? If we go through like I'm supposed to wait 7 seconds, we talked about. I waited like 0.7 seconds. 7's like awkward, but I could probably wait a little longer. Are there any questions on these three? up on the con and on the AP test, but I thought of this because it comes up on the con. So I'm pointing these two things out right here. So if I look at like number 4, increase the sample size by a factor of 9. First of all, if I increase the sample size, is my width going to increase or decrease? It's going to decrease. I have more information, so I can be a little more specific about my interval. So as n goes up, the width goes down. But it doesn't go down by a factor of 9. So like if your sample size gets 9 times bigger, your width won't get 9 times smaller. It will get 3 times smaller. Why? Where is the n in the formula? It's underneath the square root, right? So if I make something 9 times bigger, by the time I square root that 9, well, it's only going to have an impact of 3 because that 9 that we multiplied by is inside of a square root. So you have to square root the number that changes to find how much it changes by. That was a weird explanation, but I think if I do a couple, you'll get it. If I decrease the sample size by a factor of 16, so if I decrease the sample size, does the width increase or decrease? It will increase. But it won't increase by a factor of 16. It won't get 16 times bigger. It'll get how many times bigger? 4 times bigger. Because if I make that number 16 times bigger, the overall impact that it has is only 4 because I have to square root that number. Does that make sense? Point out here. Try the next two. And this does come up on your con. It's basically like these questions.
It has functions instead of increase, decrease.
Oh, so like 1, 9, 1, 30. Which one? No. Well, first of all, increase or decrease? Increase. And then it's just the square root of the number. So sample size and width are opposite. So if this goes down, this one's going to go up. And it's tempting to say, well, sample size decreased by 4, so we're going to increase by 4, but it's actually the square root of that number, so this would be 2. If I increase the sample size, the width is going to decrease. If I increased it by like 25 times, it would decrease by a factor of 5. How many of those last two? Those are good. Okay, good practice on the con too. All right, let's take out the packet that I gave you guys yesterday. Start working through some of those.
You got any more?
No, sure.
I just want to.
Give me a second. Somebody else need one of these? Somebody else not here yesterday? All right, we're gonna skip a few of these. at the bottom.
So David, how did you organize this?
Oh, there's 213s.
They're just like, I go through old AP tests and cut out questions that are relevant to this topic, so the numbers are all scattered. Like, I didn't write them, I'm just cutting and pasting. And no, I didn't put them in order for you, I'm sorry.
Well, you said 13. I looked at the top one and I was like, that doesn't look like it.
Oh, I didn't even look at, yeah, sorry, I didn't know there was 2 13. So the 13 at the bottom. I guess that was kind of your point, huh, Logan? I got it eventually. Why are you, that's what we just did. It's like literally the warm up, just with different numbers. So the margin of error
It's the 6.
is the 6.
Oh, it is? Oh.
So 0.06.
That's what I was confused about.
There's your 90%. And then we don't know P. So what do we use? P equals 0.5. I'm gonna show you another way to do this too after you do this. I want you to try this first. It's like 188, I think.
Yeah.
And they go up to 200. Big rounds. So I believe it's 187 point something, and then you round up to 188. Let me show you like another way to do this that you might like better. So you can really take advantage of the fact that it's multiple choice. I'm gonna do a 1/4 Z interval, and I'm gonna start with the like. Let's say the answer is A. They didn't tell me P, so I'm gonna assume it's 50%. So if my sample size is 100, like in option answer A, the sample size is 100, and 50% is what I'm supposed to use, that might actually be 50 out of 100. My confidence level they gave me is 0.9. If I calculate that, my middle is 0.5. So if the margin of error is 0.06, like that's too big. So this goes from 0.41 to 0.58. The middle is 0.5, and if I can only go 0.06 each way, it needs to be like inside of 0.44 and 0.56. Does that make sense what I'm saying there? It might or might not. This is a different way to do it. The middle is 0.5. I get a 6% margin of error, I can only go out to 0.44 and 0.56. Well, these two are beyond that. So if I need to make my interval smaller, I need a bigger sample size. So 100 was not the answer. It didn't work because I got bigger than a 6% margin of error. Some of you might not like this way. Some of you might just go through like an option for you. So let's say I didn't want to do 125 because it's decimal. So then I was like, all right, let's say it's 75 out of 150. If I calculate that, is that outside of the 6% margin of error, or is that okay? That's out. It's like just outside of it, right? Because it's to the left of 0.44 and it's to the right of 0.56. So 150 is not big enough. So then if I go, okay, let's say it's 200. You know, when you press enter, it erases the. So do you see how that's inside of the 0.06? So that's the smallest number that made it inside of the 0.06. So the answer is D. And you can do the algebra. And that's fine, but that's just like another way. You might get stuck, forget the algebra, want to double check it somehow. How many had D? Questions on that one? Alright. Turn the page. And try number 19. Jessica. Actually, you're gonna try that whole page. Number 9 is pretty tough. But try this page. Well, I'm sure we'll need to go through 9. That's totally fine. We'll go through whatever you want. Don't freak out if you don't get 9 at that point. I forgot to ask you that. So you guys want to go to the playground? Was it this class that had this? It was. But you hope it's like material behind. So you just like 31. That's like the number of successes, and that's the sample size. That number also knows that's 5. You know, you didn't know where. So that's your point estimate, plus or minus the critical. Like that's that part of the formula. The good news is it was in every answer. So. Go ahead. That's like this number here. saw your face for a second. Yeah. Took a drink a minute ago. I wasn't like surprised. You know, some people that took the mask off and you're like, oh, that's not what I expected. Yeah, you were. It made sense to me. I'm not saying good or bad. I'm not gonna comment on a student's appearance. Are we good on? So nine's rough. If you're struggling at nine, that's okay. Are we good on the other two? All right. So 19. The number that goes in this spot is your point estimate, which is like your p hat. They told me 31 out of 100, so that's 0.31, but that doesn't help me because every single one of those have 0.31. Number that goes in this spot is inverse norm 1.95 divided by 2. That's 1.96, right? So that's 1.96, so then I can eliminate that and that. And then the number that goes in this spot is always supposed to be the number, like these two are always going to be the same. That's your p hat. So that gets rid of this one. When would that be a 0.5? We don't know. And so then the only difference is the number down there. And which one of those is your sample size? Your sample size is 100. So that's E. Alright for 19? Let me go to 17, because 9's rougher. So the point estimate is just what's right in the middle of those. So literally you can just add them up and divide by 2, and you'll find what's right in the middle. So 0.048 plus 0.112 over 2, you just find the average. That's 0.08. And then if you notice, like, if you were to kind of sketch it out and like do subtraction, those are the same distance from the middle, so it matches. Number 9. So I'm gonna write out my like margin of error equals 0.027 formula. We're just missing a different piece than we usually are. So Z star times what's P? So this is PQ over N. Z star I don't know. They didn't tell me the confidence level. P is 0.6, so Q is 0.4, and N is 900. Like they actually gave me that. So I can get that. And then I can figure out what this is. So 0.6 times 0.4 divided by 900 square rooted is like 0.01633. So could I find out what Z star is? If I divide, or am I going too fast? So if I divide both sides by the 0.01633, I get 1.65, and you might be like, well, what are you talking about? Because 1.65 is not one of your choices. So that's your Z star. How do you find Z star? Inverse norm of 1 point whatever divided by 2. So then you do inverse norm of these and see which one gets you 1.65. So like if I do inverse norm of 1.8 divided by 2, I get 1.28. So that wasn't it. Try the next one. I do inverse norm of 1.9 divided by 2. I get 1.65. So that's the one that matches. So it's a little goofy because they left a different part than usual blank. And then even once you found it, you had like another step to get to. How many got that before I went through it? Okay. Does that help when I go through it? Does it make some sense? 24. So we've got 100 divided by our p hat is 100 divided by 432, which I'm assuming is 0.231 because I know it's not 100. So it's one of these two, and then everything else is the same except for those two numbers. So I'm just going to check with, and I'm starting to remember by now that 95% confidence interval is 1.96. And I can check it, but it's kind of in my head at this point. How many ID there? 26. Next one. This is kind of nice. You don't have to actually solve it for any. You just look for the equation that's set up the right way. So first of all, they give me 98%. So if I do inverse norm of 1.98 divided by 2, I know it's not 1.96, so assuming it must give me 2.33, that's the only choice. I would put 0.5 there if I didn't know the percentage. What we do is 0.79. And then what goes over here is the margin of error that they gave me, which is 2.5%, so 0.02. How many D? Next one. What? I thought you were gonna die for a second. It was like you sneezed before the first sneeze was even done. You sneezed within a sneeze. Alright, so my p hat always goes in this spot, is 180 divided by 300, which is 0.6. So I get rid of those two. And then my confidence interval is 98%, so if I do inverse norm 1.98 divided by 2, that's 2.33. That was up. I think the other part's the same problem. How many did see there? Questions there? One more. Go back to the beginning. It's the other 13, like the very first 13 I put out there. I want you to try. This is a little tougher one too. You guys got it. So the standard deviation for example proportion is that. That's why we write it there in the formula. So that's your standard deviation formula. What combination of those things would make this as big as possible? That's the question. So like one thing you can do is just be trying to plug it up. you get. Try it again with p close to 1. You know what I'm saying? Just like try different numbers and see what happens. Yeah, remember that a smaller n creates a bigger margin of error, which is basically standard deviation. So the smaller n creates a bigger standard deviation. So it's not going to be any of these three because those are the bigger n's. And then so if you just try like let's say 0.05 times 0.95 divided by 100, and then like 0.5 times 0.5